Hello viewers, we're now taking you through the story of O-level physics, and this video I'm going to look at the part of arrangement of resistors in a circuit. So this video is under the topic of current electricity and is suitable for students in both senior 3 and senior 4. So the calculations under current electricity can be divided into 5 parts, which are these. So the first part, we have already looked at it, and now we are going to look at the second part, which is arrangement of resistors in electrical circuit. So here we are interested in calculations, but full notes are available in these books, in the book Mastering O-Level Physics, Volume 2. So Volume 1 is for Senior 1 and Senior 2, and Volume 2 is for Senior 3 and Senior 4. It has clear notes, worked examples, trial questions, and their answers. Also, we have a topical question bank of O-Level Physics from the year 2020 up to 2000. So this bank has topical questions and also with their marking guides. By marking guides, I mean the solutions to those questions, marking points, and comments where necessary. We also have a mathematics topical question bank for UCE. So if you need any of these copies, you can contact the author on any of these contacts. So arrangement of resistors in a circuit is in two ways. They can be arranged in series or arranged in parallel, or a combination of both series and parallel, and we shall look at all those three parts. So let's start with series arrangement of resistors. So in series arrangement, the resistors are connected end to end, and the same current flows through all the resistors. But the total PD is not the same. It is the sum of the individual PDs. So for series, 1, the resistors are connected end to end. 2, the current is the same through all the resistors. And 3, PD is the sum of the individual PDs. So you shall see that what that means with the aid of a circuit diagram. So in this diagram, we shall consider R1 and R2 to be the resistors which are connected in series. So in this case, this V is the total PD from the dry cell, and this V1 is the PD across R1. Remember, we saw in the previous video that V is equal to IR. So because we have I and R, they should be PD. Also here, because we have I and R, they should be a PD. So V2 is the PD across R2, V1 is the PD across R1. And when you add this PD to this PD, you'll be able to get the total PD. That's what it meant here. The total PD is equal to the sum of the individual PDs. So therefore, V will be equal to V1 plus V2. And you also know from Ohm's law that V1 is equal to IR1 and V2 is equal to IR2. So what we shall do, we shall substitute for V1 and also for V2. When you do that, you shall come up with this. Then here, I is common, so I'll factorize it out. Then I can take this I this side. Then I remember that since V is equal to IR, it implies that if R is the effective resistance, effective means total resistance in a circuit, then V over I is equal to R. Now substituting for V over I here, I'll come up with the rule which I'm interested in. That is R is equal to R1 plus R2. So that implies that 1, for series arrangement, the current is the same through all the resistors, and 2, the total PD is equal to the sum of the individual PDs, and 3, the total resistance is equal to the sum of the individual resistances. So this current is measured using an instrument called an ammeter, while PD is measured using what we call a voltmeter. So when you see the word voltmeter reading, it implies it is the value of PD. And when you see the word ammeter reading, it implies that will be the value of current. So now we shall go to question 1. Question 1 came from UNEB 2003, paper 1, question 23. And it says, 2 resistors of 2 ohms and 3 ohms are connected in series with a 10-volt battery of negligible internal resistance. So this word internal resistance, we have not yet known what it means. But the good thing they have said, it is negligible. So we neglect this word internal resistance. We shall see what it means in the next video. The potential difference across a 3 ohm resistor is, so they want you to get the potential difference across the 3 ohm resistor. 1, because here we have total PD, therefore total resistance, we have to first get the total current, because current is the same through all the resistors. But to get total current, we need to total resistance. So total resistance will be got by adding the individual resistances to come up with 5 ohm. Therefore, now that we have total resistance, we can get total current by total PD over total resistance. Total PD is 10 volt and resistance is 5. So we come up with 2 ampere. So now that we know the current, we can easily get this PD by multiplying this current with that PD. So PD across the 3 ohm resistor will be equal to IR. I is 2, R is 3 to come up with 6 volt. So that means that option C is the correct answer. Then question 2 came from UNEB, paper 1, question 37, and says, in figure 7, the ammeter reads 4 ampere and the voltmeter reads 4 volt. Find the value of R. So voltmeter is the PD across the 2 ohm resistor, and the ampere is the total current, because current flows from the positive terminal through the resistors and back through the negative terminal. Therefore, we know the total current, which is this, and we know the PD across the 2 ohm resistor. But remember what they said, total PD, which is this, is the sum of the individual PDs. So if this one takes 4 volt, it means this one will take 12 minus 4. Okay, so that means that now 12 minus 4 will be 8 volt, and that will be the PD across R, and we know the current through R. That means we can use V equal to IR to come up with the value of R. So V is that, I is that, and R is what we want. So making it the subject gives you R equals 2 ohms, meaning B is the correct answer. Then question 3 came from UNEB 1997, paper 1, question 35, and it says 2 coils of wire of resistances 2 ohm and 3 ohm are connected in series to a 10 volt battery of negligible internal resistance. That means we neglect this word internal resistance. The current through the 2 ohm resistor is, so they want the current through the 2 ohm resistor. In question 1, it was similar. This question is similar to question 1, but for question 1, they wanted the current through the PD across the 3 ohm resistor. Now they want the current through the 2 ohm resistor. What we should remember is that for series, same current flows through all the resistors, meaning this current through the 2 ohm resistor is equal to the total current. Therefore, our aim is to get total current. And to get total current, you need total resistance. So I is equal to V total over R total. So total PD is 10, and total resistance we already saw in question 1, that's got by adding the individual resistances to come up with 2 ampere, and that will be the current they want. Therefore, option B is the correct answer. Then question 4 came from UNEB 1991, paper 1, question 35, and it says, in the circuit diagram in figure 10, the ammeter reading is 0.2 ampere. The reading in volts shown by the voltmeter is, so they want the voltmeter reading. So this voltmeter reading is connected to the source of the PD, meaning that they want the value of the total PD. So to get total PD, you need total resistance. Therefore, we shall come and first get the total resistance by adding all the individual resistances to come up with 60 ohms. After total resistance, and we know total current, we can get the total PD, which is the voltmeter reading, I times R, to give you 12 volt. That means that option D is the correct answer. So that was series arrangement. What about parallel arrangement? For parallel arrangement, the resistors are connected alongside each other. We shall see what that means when you draw a circuit diagram. And PD is the same. So in series, PD was different, but current was the same. In parallel, PD is the same, but current is different. Those are the two differences you need to be aware of. And also in series, the resistors were connected in line with each other, but here it is alongside each other. So to draw a circuit diagram, we shall consider two resistors R1 and R2 connected in parallel. Then we can now draw our circuit diagram. Okay, so these two resistors are in series, are in parallel, because if this current moves from the source, it will reach this junction and split. One will go this side through R1, another one will go this side through R2. Then at this point, it will combine and go back to the source. So because different currents pass through R1 and R2, it implies that they are in parallel. So that is one way of distinguishing between resistors in parallel and resistors in series. For those in series, it is same current. For those in parallel, it is different current. So here it is I1 from the source, but when it reaches here, it splits. So this I splits, one I1 is there, and here it is I2, so it is different current. But when it reaches here, it will combine to give the same reading as it was before splitting. Okay, so this current divides into I1 and I2, meaning that I is equal to I1 plus I2. So if R is the effective resistance of the system, it implies that I is equal to V over R, and I1 is equal to V over R1, and I2 is V over R2. So you're using the same value V because for parallel, PD is the same. So the PD across this and the PD across this is this one. So when I substitute into I equal to I1 plus I2, we shall come up with that. Cancel out the V's, come up with that. Get the LCM, come up with this. And get the reciprocal to come up with this. Reciprocal means when this one goes up, this one goes down. Similarly, when this one goes up, this one goes down. So the total resistance is product over sum. Therefore, in general, we can say that total resistance is equal to product of two resistors over sum of two resistors. So the resistors, to use this formula, the resistors must be only and only 2. If there are more than 2, we cannot use this. We have to go back and use this one. But the good thing is that for our case, they use 2 resistors. So in summary, the following can be noted. We can remind ourselves that for parallel, total current is equal to the sum of the individual currents, and total PD is the same across all resistors. And lastly, effective resistance is less than the least individual resistance. For example, if one resistor is 2 ohm and another one is 5 ohm, it means that your effective resistance must be less than 2 ohm. So with that, we shall go through these questions. Question 1 came from UNEB 2012 paper 1 question 2011 paper 1 question 22, and says find the effective resistance of 2 resistors 4 ohm and 6 ohm connected in parallel. So there we know that effective resistance is product over sum. So we shall come and substitute, use a calculator to come up with this. Therefore, option C is the correct answer. Then question 2 came from UNEB 1993 paper 1 question 15, and says a current of 2 ampere flows in a circuit in which 2 resistors each of 3 ohm are connected as shown in figure. Calculate the PD across XY. So these resistors are in parallel because at this point current divides. So what we need to know is that this is the total current, and the PD across this is equal to the PD across this, and is equal to this source PD, or the total PD. So what they want is the value of the total PD. To get the value of the total PD, we first need total resistance. So resistance will be product over sum to give you 1.5 ohm. And after getting total resistance, and we know total current, we can get total PD. So total current times total PD, you come up with total current plus total resistance gives you total PD. Therefore, option B was the correct answer. Then question 3 came from UNEB 1990 paper 1 question 32, and says calculate the current in the 2 ohm resistor in the circuit in figure 10. So these two are in parallel, and the current they want is the current which goes through these 2 ohm. So what we realize is that the PD across this 2 ohm is 4 volt, because we said it is the same throughout. So now that we have the PD and the resistance, we can get the current. So current will be V over R. So V is this PD and R is this current of interest. Sorry, R is the resistance of interest. That gives you a current of 2 ampere. Therefore, option C was the correct answer. Then question 4 came from UNEB 2007 paper 2 question 3C, and says what will be the reading of the ammeter in figure 1 if switch K2 is open and K1 is closed. So when K2 is open, when K2 is open, this is K2, it is open, it implies that when current reaches this side, this one is closed. When current comes and reaches this side, it cannot go through this path because it is open here, disconnected. That means that all the current goes through the 4 ohm resistor. What does that imply? It implies that this resistance is out of the circuit when K2 is open. Therefore, the total resistance is 4 ohm and total PD is 3 volt, meaning I can get the ammeter reading because I know V and I know R. So let's first do that. So ammeter reading will be V over R. V is that, R is that, to give you 0.75. For Roman 2, when both are closed, when this is closed and this is closed, it implies that this is now in the circuit. Therefore, when current comes out here, it divides, one goes this side, another one goes this side. That means that these two are in parallel. And because they are in parallel, we have to first get the total resistance. And we also already know the total PD, meaning you can get the total current. And that total current is the ammeter reading. So you come here and remember that for resistors in parallel, they are got by product over sum. So that will give you 4/3 ohm. Then I'll come and say that using V equal to IR, ammeter reading will be V total over R total. So V total is 3 volt and R total is 4/3. When you use the calculator, you'll come up with 2.25 ampere. And that's what they wanted. So previously we have been looking at series arrangement independently and also parallel arrangement independently. But what if in one circuit there is both series and parallel arrangement? So this is what we are going to look at in this part. So question 1 came from UNEB 2011 paper 2 question 6e, and it says resistors of this and that are connected as shown in figure 5 across a battery of EMF 2 volt and negligible internal resistance. So this word internal resistance will be looked at in the next video, but the good thing they have said it is negligible, so you neglect it. So it's the circuit, and they said calculate the current through the 4 ohm resistor. So current moves from here through this, meaning the current through the 4 ohm resistor is the total current. When it reaches here, it divides. One goes this side, another one goes this side. And at this junction, it combines to go back to the source. So because here it divides, it implies that this resistor and this resistor are in parallel. And remember, to get the total current, you have to first get the total resistance. So we are going to first combine these two resistors in parallel. Let's do that. So combining this and this in parallel, we shall use product over sum to come up with 1.2. Now when you combine the two, it implies that the two resistors become now are replaced with one resistor, which is 1.2 ohm. And that implies that now what we have are resistors in series. This is in series with this because same current flows through both of them. Therefore, resistance in series, we got it by adding individual resistances. Therefore, total resistance will be given by adding. Okay, and now that we have total resistance and total PD, remember total PD was 2 volt, it implies that we can get total current from V equal to IR, implying that I is equal to V over R, V is that, R is that, to give you that as the current. So that will be the current through the 4 ohm resistor. Then question 2 came from UNEB 2002 paper 1 question 50b, and it says Roman 1, what is the effective resistance in the circuit in the figure? The cell has negligible resistance. So they want the total resistance of all these resistances. So first we should remember that here, from the current from this source passes through this, reaches here, it divides. One goes this side, another one goes this side, meaning that these two resistances are in parallel. They are the ones which are first combined to get one resistor. So let's first do that. So combining these ones in parallel, we use product over sum to come up with 2 ohm. When we get 2 ohm, it implies that the ones which were 2 are now replaced by one resistor, which is now 2 ohm. And when you look at that circuit, these two resistances are in series because the same current through this is the same current through that. And resistances in series are got by adding. So we shall come and get our total resistance by adding the 2. So that was Roman 1. What about Roman 2? For Roman 2, they said what will be the reading of the voltmeter when the key K is closed. So reading of the voltmeter, they want the PD across this 2 ohm resistor. The good thing, we know the current. If we go back here in this circuit, from here it now goes, the same current flows through both resistances. That means that we have to first get the current, the total current, and to be the current through this resistor. So let's first get the total current. Total current is V over R. So R is the total resistance and V is the total voltage, to give you 1.5. And now that I know current and I know this resistor, I can easily get the PD. So therefore voltmeter reading will be IR, which is I is that and R is this 2 ohm resistor, which is of interest, to give you 3 volt. Then question 3 came from UNEB 2006 part 2 question 4C and says a battery of EMF 12 volt and negligible internal resistance is connected to resistances, these ones, as shown in figure 3. Find the reading of the ammeter when K is closed. So the reading of the ammeter is the value of I2, so that's what we need to get. But to get the value of I2, we need to first get the total current. So total current means that we are going to combine. Remember, if you look at this, this is I1, this is I1, this is I2, meaning these 2 resistances are in parallel. So let's first combine the 2 resistances, and get after that we shall get total resistance, then total current, and we shall think of how to get that I2. So let's first get the resistance in parallel. So when I combine these 2 in parallel, I come up with the product over sum, which is 2 ohm. That means that those 2 resistors will be replaced by 1 resistor, which is now 2 ohm. Okay, and now when you look at it, current flows, the same current flows through both resistances, meaning they are in series. And for series, we just add the individual resistors. So we shall come and get the total resistance by adding. Okay, so now that we know the total resistance and the total PD, which is 12, we can get the total current. V over R, V is 12, R is 4, that is total current of 3 ampere. So now we know the current. We know the current through this resistor and this resistor. That means that we can easily get the PD across this combined, this resistor which was in parallel. So PD across parallel combination is V equal to IR. So I is the total current and R is this combined resistor. That's why you see here 3 times 2 to give you 6 volt. Now that 6 volt, it implies that when you go back to our original diagram, remember these 2 are in parallel, meaning they have the same PD. So PD across this is 6 volt and PD across this is 6 volt. Okay, so now that we know there is the PD across this 3 ohm and it was 6 volt, and we know the resistance 3 ohm, we can get this current from V equal to IR. So we shall come back here and so that the ammeter reading I2 is equal to V, which was the PD across the parallel combination, over the resistor of interest, that is 6 over 3, to give you 2 ampere. Then question 4 came from UNEB 2000 paper 1 question 9 and says a source of EMF 20 volt and negligible internal resistance. So internal resistance for now, it is negligible. In the next video, that's when we shall look at internal resistance connected to resistors 2, 2 and 3 as shown in figure 11. Find the ammeter reading when switch K is open and when switch K is closed. So we shall first consider when K is open. When it is open, it implies that this resistance is out of the circuit. So what remains is this and this. And the ammeter reading is the total current. So current flows like that. It no longer goes through this resistor. So that means that now the circuit becomes like this. Where the same current through this is the same current through this, meaning they are in series. And because they are in series, total resistance is got by adding. So we shall come and add to get the total resistance. Then after getting total resistance and we know total PD, we can get total current from V equal to IR. So I is equal to V over R. So V is 20, R is 5, giving you 4 ampere. That was Roman 1. What about Roman 2? For Roman 2, they said when K is closed. Now, when this is closed, it implies that this current, total current, goes through 3 ohm, but when it reaches here, it has to divide. One goes this side, another one goes this side. What does that mean? It implies that these two resistors are in parallel. And because they're in parallel, we have to first combine the two. And also remember that this ammeter reading is the total current. Okay, so we shall come back here and first combine the two resistances in parallel using product over sum to give you 1 ampere. So that means that these two resistors are combined into one resistor which is of 1 ampere. So now the same current flows through the 3 ohm and the 1 ohm, meaning that these two are in series. Because they're in series, the total resistance is got by adding. So you can get the total resistance by addition, after which you can get ammeter reading from V over R to give you 5 ampere. So now we shall go to question 5, which came from UNEB 1993 paper 2 question 6c, and it says 4 resistors are connected across a 12-volt battery of negligible internal resistance as shown above. So it's the circuit. Then part A, they said Roman 1, determine the reading of the ammeter. Then also the PD across the parallel combination of resistors. So this current flows from this, goes through this. So total current is the ammeter reading, and it goes through the 3 ohm, reaches here, it combines, it splits, one goes this side, another one goes this side, it combines and goes through the 4 ohm. That means that these two resistances are in parallel. So before we get the total resistance, we have to first get those two resistances in parallel. We shall come here and say that for parallel, remember we use product over sum. Therefore, you shall come and use our product over sum to come up with 1.2 ohm. That means that when I combine those two resistances, I'll come up with this circuit. They're being replaced by this one. So now the current from here, the same current flows through all the 3 resistances, meaning they are now in series and the total resistance can be got by addition. Therefore, we shall come and say that total resistance will be equal to the sum of all the 3 to give you 8.2. And now that we know the total resistance and the total PD, which is 12, we can get the total current from V equal to IR. Therefore, I will be V over R. V is this total PD, R is the total resistance to give you that. And that will be the ammeter reading. Then for Roman 2, they wanted the PD across the parallel combination. They want the PD across this. So the PD across that is the same, is the PD across this resistor, because it was the effective resistance after combining. So the same PD across this resistor. Now the good thing, we know the current flowing through that resistor and this resistor. So shall just multiply the current times this to get the PD they want. So this is the current and this is the PD. So this is the resistance to come up with the PD which they want. So that brings us to the end of this video. Thanks for watching, and be reminded this video will be on electromotive force and internal resistance of a cell. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that you can all benefit as a family.